I've now got the electronic lead screw made up and working. It's the one by Clough42, and it's thanks to his help that I finally managed to get this working. I've had a few trials and tribulations with it, which were partly my fault and partly a fault on the board. The alterations to the lathe are almost zero, very, very minimal. This is the original bracket that supported the gears for manual gear cutting. They're taken off, the gears are, and then I substituted here a tooth pulley here and a same equal sized tooth pulley here, and in here is the encoder, and this is on a one-to-one relationship, so as this turns round it turns the encoder, and the encoder sends a pulse signal, and it's 1,000 pulses per revolution on the encoder, and that's really very, very simple. The encoder I used is this Omron encoder, which I bought from China, very cheap, and I was surprised I didn't have problems with it. I thought there were warnings on the internet of fake ones and ones from China not working, but I didn't have any problem at all. And then the electronics are all situated in the white box here. There's the panel on the front, which has all the controls on it. Down below here are the motor controls for the lathe, and this is very, very simple. There's not much to this. There's a power supply for the 240 volts, and there's a 5 volt power supply to supply the main part of the electronics, and the main switch down here to be able to switch it. And I've used these plug-in style connectors, which aircraft style connectors, which are excellent. Let's move that up a bit. These ones here, aircraft style connectors, very, very good, and if you can find them, they're worth buying. So that's all there is for this side. I'll move round to the other side of the lathe, explain what I've done there, and then come back and open the box up. Right, I've moved along a little bit, and on this side you can just see sticking out the connector that takes the servo motor. On this part of the lathe, obviously with no lead screw, this effectively is the lead screw, and I had to renew the lead screw because its direction was going backwards as it was originally supplied. So if you have the manual gears on the shaft at the back, you have to have the thing working so that as you turn the handle, you turn it backwards to get the lathe to advance, which is nuts really. I don't know why they did it like that. The rest of it, the back gearing and everything else, is very standard, and this shaft as well was running back to front. So I replaced both of these, both this and feed screw and that feed screw, which meant I had to fit a new nut for the feed screw underneath there. This is the nut that I have for the one that goes back to front, and I threaded this one myself. So it can be done in your own workshop. It's a little difficult to turn Acme screws with a tap, but it can be done. Best to hold them in a collet chuck, tightened up nice and tight. So when I have to change it, there's a little pin which you can just see there, and that comes through there. When I want to take this off, I just knock through that hole there, and tap that little pin out. That allows all this to come off and then unscrew through to the back of the lathe. So I'll move this up a bit further. Now it's not dreadfully pretty, but at least it does the job. There are two screws here. That's the one that this plate here pivots on. And you can see there's an elongated hole here. So I can move this up to slacken the belt off and take the belt off fairly easily. This is just a little bit of protection to make sure that I don't brush against the belt while it's going round, but I don't see how I would, because when you're working on the lathe you're more up against the chuck side of it than that end of the lathe. And the manual handle still works. It's easier to turn if you undo these and just slacken this off, take the belt off, but most of the time I can see that anybody who's operating with an electronic lead screw is like to use the drive because it's so seamless and works well. But anyway, this is reversible back to the way it was at the beginning. There are no holes drilled anywhere in the lathe. These are the two original mounting screws, and this plate here sits on a bush that's located on the original setup through a hole, and it's all demountable. So I was pleased with how that worked out. With thread cutting, what I found is that the best way to do the cutting, to move this little collar round, it's very tight unless you put a screwdriver in this gap. Move that back a bit and just make sure that's in focus. You have to put a screwdriver in this gap, just wedge it in. So I think cutting threads much better to say start 0 out at 20 or whatever the figure is, and then make a turn and go past the turning point by 0.1 of a millimetre to start with, and then move this, when you've done it, back to 0 again, and then turn it round again. This is my first attempt at cutting a thread. That's an M10. I hadn't got an M10 nut, so I just took out a piece of stock, drilled it out and tapped it, and it fits fine in there. The electronic screw thread seems to work very accurately. There was no question of there being any threads being crossed or anything like that. See, it's a beautifully clean thread, so that I'm happy with. I found you don't want to be too keen to cut the thread in one go. You've got to do a fair number of passes, and I cut everything manually rather than running the lathe as I did when I used the feed to turn things down. If you cut a thread, what can happen, as I've discovered, is that there's so much weight of cast iron here in the gears and everything, especially when you're running back gear. If you stop the feed, turn this out and switch off the lathe, it doesn't stop turning until maybe 4 turns later. So with that as a problem, there is a danger in running into the shoulder that you're coming up to. So you have to be pretty careful. I think it's alright when you're using it for turning, and I seemed reasonably comfortable. I wasn't going to make a mess of that. But certainly with the thread cutting, you've got much more control to do it by hand. The thread cutting, when I'm cutting by hand, I made up a simple arrangement that I had on my Boxford lathe with a handle, and just plug that into the headstock at the back, and that works perfectly. I don't have a feedback on the stepper motor. It's just a plain straightforward stepper motor. When you're cutting something, or turning something down and it's not thread cutting, it really doesn't need anything special. You're not worrying about it missing a step here or there, but I don't think this does miss a step. And this is a stepper online stepper motor from China, 4.2 amps, 3 newton meters of torque, and that seems quite adequate on a 1-to-1 ratio on the pulley at that end, and the whole thing works pretty well. And you need to really go onto YouTube and see Clough42's series of how to do the programming and how to set up the software and so on. Now I'll just take this box off. I haven't drilled any cooling holes and I haven't put a fan in here yet, but I may or may not, I haven't decided yet. It doesn't seem to get very hot, so I'm more inclined just to leave it, I think. But no doubt someone will criticise me. And that's all there is inside the box. This is a 42 volt transformer. This is a fairly simple stepper motor with no stepper motor driver with no feedback. This particular one is a 5056 stepper motor that I bought from America, but it could just as easily have been any other stepper motor driver. And then this is the board in here, which is a TI board for projects that Clough42 uses, and has a chip on it that needs programming. And he provided the green board which sits on top of it to give slightly easier access to the pins and things. So it's really quite simple in there. That's the back side of the push buttons and the switches. I mean, you could do this all sorts of different ways. That just happens to be the way I chose to do it. Now I'll just go through some of the features and see if so you can just see the chuck turning over and the slide moving. When you switch on, it displays immediately the imperial side, but there's a switch here which is millimetre or imperial, so there's inch, so that's millimetres, and it's on feed or thread. At the moment it's on feed, and if I do that, that's cutting a 1/2 millimetre thread, and these are the various thread options it allows you to cut. And you can do forward and reverse by setting this button, and in here is the display of the RPM. So I can just show you quickly how you can cut a thread by running this or operating it manually. And if you wind backwards, it goes backwards. And it doesn't, the stepper motor doesn't seem to be under any distress at all when it's turning, and you get a better feel for it when it's turning with something in the chuck, and you can feel whether it's cutting and if it's labouring over it. But so far it looks pretty good. I can cut 1.5 millimetre depth of total depth of cut on a diameter, so that's 3/4 of a millimetre depth of cut on the radius. The feeds, let's get that back to feeds. I found I was getting quite good results with it fairly low. And you certainly in metric wouldn't want to be running 0.5, that's miles too coarse. So 0.1 is a good starting point. Alright, I think what I'll do is I'll set the camera up and then cut turn a bit and then cut a thread, just so that you can see it in operation. This is 1/2 millimetre depth of cut, i.e. reducing the outside diameter by 1 millimetre. This is mild steel. And this is a cut 0.7 of a millimetre. And you can see how much everything freewheels about 4 or 5 millimetres, so you have to be a bit careful of cutting up against the shoulder. And that's reversing using the display and the feed screw. So there's no sign of it bogging down, and that seems to work very well. I've got a little bit of play somewhere in here. I'm not quite sure whether that's the spindle needs just tightening up a little bit more, because it's moving slightly as it goes in, and also this isn't a particularly good cutting tip, so it's not quite as rigid as it might be. As I say, I think it's in the bearing there not being quite tightened up. Right, so I'll now cut a thread so you can see it thread cutting, and I'll do that with it turning. I'm just going to move this zoom out so that you can see a little bit more of what goes on at the back, to show you it really is being cut by hand. And you've got ultimate control over where the thread stops. And you'll notice I did forget to cut a bevel on the edge and a gutter at the back, but it really doesn't matter because you have such good control over it. No, not quite. It's just a little tight, but it is going on. Right, that's the thread finished and cut, and I'll just put the nut on. Pretty near a perfect fit nut, so I'm happy with that. Cuts a decent thread, it's nice and clean. I didn't show you earlier, but this is the board. Just zoom out a little bit. This is the TI board, and that's the Clough42 board, and the chip is in the middle there, but it's programmed. There's nothing on the rear of it, and these are relatively inexpensive, as is Clough42's and the software which he's made available. It really is an excellent solution, particularly if you've got a lathe that doesn't have change gears and you can't cut threads, because this will cut any thread within the list that they've got on here of imperial or metric. And I cut 20 threads per inch, 30 threads per inch, and it will work fine. So a very good system and to be recommended.